New assignment. First question is, what is admixture? Admixture, a mineral other than cement, water and aggregates that is used as an ingredient of concrete and is added to the batch immediately before or during mixing is called as admixture. Admixtures are used in concrete to improve a certain property of concrete. The properties which are commonly modified by admixtures are rate of hydration, setting time, workability, dispersion, and air entrainment. Generally, the quantity of admixtures added is small. These days, concrete is being used for wide varieties of purposes to make it suitable in different conditions. In these conditions, ordinary concrete may fail to exhibit the required quantity, perform, or durability. In such cases, admixture used to modify the properties of ordinary concrete so as to make it more suitable for any situation. A degree of control must be exercised to ensure proper quantity of the admixture, as an excess quantity may be detrimental to the properties of concrete. The effectiveness of an admixture depend on several factors including types and quantities of the cement, water content, mixing time, slump, and temperature of the concrete and air. Then second question is, write down a classification of admixture briefly. What are the classification of admixtures? The admixtures are classified into the various ways as a plasticizer, super plasticizer, accelerator, retarder, grouting admixtures, air entrainment admixtures, air returning admixtures, gas forming admixtures, expansion producing admixture, waterproofing admixtures, corrosion admixture, fungicial admixture, bonding admixtures. There is a various classification of admixtures. First is the plasticizer. Plasticizers means water reducer. Reduce water requirement and to increase workability. High range water reducer, that is plasticizer. Super plasticizer, improved version of the plasticizer is the super plasticizer. Then third is the accelerator. Accelerate the hardening process, so use for urgent repair work is a accelerator work. Then retarder, slow down the chemical process of hydration, so use in hot weather. The retarder purpose, slow down the chemical process of hydration. Grouting admixtures, then after air entering admixtures produce air bubble, hence increase the fluidity of the concrete. Air detaining admixtures helps to remove excess air bubbles. Then after gas forming admixtures, which reduce gas bubble for lightweight concrete. And expansion producing admixtures and the waterproofing admixtures. Waterproofing admixtures improve workability, reduce water, make dense and impervious concrete. Then corrosion inhibiting admixtures, which prevents corrosion of reinforcement. Fungicidal, germicidal and insecticidal admixtures also use. Classifications may bonding admixtures increase bond strength between old and new concrete. Then next classification is pozzolanic or mineral admixtures, which is more resistant to action of salt. Also one admixture form is the coloring admixtures. These are the various types of the classification of the admixtures. Next, third question is, what are the effect of fly ash on hardened concrete? Fly ash, when used in concrete, contribute to the strength of the concrete due to its pozzolanic reaction or reactivity. However, Since the pozzolanic reaction proceeds slowly, the initial strength of fly ash concrete tends to be lower than of concrete without fly ash. Due to continued pozzolanic reactivity, concrete develops greater strength at lower edge or the latter edge, which may exceed that of the concrete without fly ash. The pozzolanic reaction also contributes to making the texture of concrete dense, resulting in the decrease of water permeability and gas permeability. It should be noted that since the pozzolanic reaction can only proceed in the presence of water, enough moisture should be available for the long time. Therefore, fly ash concrete should be cured for a longer period. In this sense, fly ash concrete used in the underwater structure such as dam will derive full benefits of the attaining improved long-term strength and water tightness. These are the effects of the fly ash on concrete. After that, question number 4. Discuss ground granulated blast furnace slag. Ground granulated blast furnace slag is another important mineral admixture like fly ash, a non-metallic product consisting essentially of silicate and aluminate of calcium and other bases. The molten slag is rapidly chilled by quenching in water to form a glassy sand like granulated material. The granulated material, when further ground to less than 45 micron, will have specific surface to about 400 to 600 meter square per kg. The chemical composition of blast furnace slag is similar to that of the cement clinker. It is a waste industrial byproduct obtained during the production of iron. The blast furnace slag is a non-metallic product having oxide composition similar to that of Portland cement clinker. That is, it consists essentially of silicates and aluminates of calcium and other bases, but it contains lesser calcium oxide. Air-cooled crystalline slag has no cementing properties. However, when cooled rapidly, it solidifies in a granulated glassy form, which is reactive with water having alkaline medium. The molten slag is chilled rapidly either by quenching it in water or subjecting the slag stream to jet of water or of jet, air and water to form a sand like grassy material. The main advantage in using blast furnace slag is in lower rate of heat evolution, refined pore structure, reduce permeability and improve resistance to surface attack. These are the overview of the ground granulated blast furnace slags. Then next question number 5 is define chemical composition of silica flume. Here the silica flume, also referred to as the microsilica or condensed silica flume, is another material that is used as an artificial pozzolanic admixture. It is extremely fine with particle size less than 1 micron and with an average diameter of about 0.1 micron, about 100 times smaller than average cement particles. Silica fume is covered under IS 15388-2003. Silica fume shall conform to the following chemical requirement as the characteristics and requirement. First is the SiO2 percentage by mass minimum 85%, moisture content percentage by mass maximum 3%, loss on ignition percentage by mass maximum 4%, alkalis as N2O percentage maximum 1.5%, Al2O3 0.8% and Fe2O3 1.5%. These are the characteristics and requirement of confirming the chemical requirement of the silica film. Next question is what are the different types of mineral admixture and explain any two of mineral admixtures. It can be divided into two groups, natural pozzolana and artificial pozzolana. And natural pozzolana, it consists of clay and shale, oblique chert, diatomaceous earth, volcanic tuff, and pumicides. These are the natural pozzolana. Then artificial pozzolana, each fly ash, silica fume, blast furnace slag, rice husk ash, metacolin, surki. These are the artificial pozzolana type. Other mineral admixtures like the finely ground marble, quartz, granite powder are also sometimes used. Out of which here we explain shortly in the rice husk ash. This is a high reactivity pozzolana obtained by controlled calcination of the rice husk. Filled burnt rice husk is almost crystalline in nature and make a weak pozzolan. Thus, to obtain a high degree of pozzolanicity, a good control is needed while burning. RHA usually contains a large amount of unburned carbon which might adversely affect air entrainment. RHA is a fine material with particle size less than 45 micron and a surface area of 60,000 meter square per kg. The particles are typically cellular. A high amount of reactive silica is present in the system, greater than 90%. Rice husk consists of 5% carbon and 2% K2O. RHA is a good super pozzolana. Rice milling generates a byproduct known as husk. This surrounds the paddy grain. During milling of paddy, about 78% of weight is received as rice, broken rice and bran. Rest 22% of the weight of paddy is received as husk. This husk is used as fuel in the rice mill. They generate steam for the parabolic process. This husk contains about 75% organic volatile matter and the balance 25% of the weight of this husk is considered or converted into ash during the firing process. It is known as rice husk ash. This RHA in turn contains around 85% to 90% amorphous silica. About 20 million tons of RHA is produced annually. These are the description of rice husk ash. Then second type of admixtures, mineral admixtures, artificially, that is fly ash. Fly ash is a byproduct obtained during the combustion of the coal in thermal power plant. Nearly 73% of India's electricity generation is through coal burning thermal power stations. Only about 10% of fly ash is being utilized in various industries. Remaining about get dumped in landfills. According to the World Bank estimate, by 2015, the disposal of the coal ash would require 1000 square kilometer or 1 square meter of land per person. Thus, the utilization of fly ash is a matter of primary concern. The use of fly ash as a concrete admixture not only extend technical advantage to the properties of concrete but also contribute to the environmental pollution control. Concrete is easier to place with less effort, responding better to vibration, to feel foam more completely. Fly ash continue to combine with free lime, increasing structural strength over time. Okay. Next question we have studied, that is question number 7, advantages of mineral admixtures. It is a supplementary cementing materials used when special performance is needed, increase in strength, reduction in water demand, impermeability, low heat of hydration, improved durability, correcting deficiencies in aggregate gradation as pillars, result in cost and energy saving. Replacement of cement lead to cost saving. Energy required to process this material is also much lower than cement. The environmental damage and pollution is minimized by the use of these byproducts. About 6 to 7% of total CO2 emission occurs from the production of cement. Usage depends on supply and demand forces as well as the market potential and aptitude. Reduce bleeding in concrete with correct proportion of all ingredients. Smaller particle size and higher specific surface area of mineral admixture are favorable to produce highly dense impermeable concrete. However, they cause low workability and more water demand, which may be offset by adding effective superplasticizer. Mineral admixtures increase the cohesiveness of the concrete and require more water to maintain workability. Then next question is, what are the function of admixture? Admixture are used to accelerate the rate of hydration and used to reduce the initial setting time, used to increase the strength of concrete, used to improve the workability, reduces the heat of hydration, help in improving the durability of concrete, help in controlling shrinkage, creep and swelling of concrete, increase the impermeability of concrete, improve the pumpability of concrete, used to increase the bond between old and new concrete layers, prevent the corrosion of concrete, increase the resistance to chemical attack, used to produce cellular concrete, used to produce color concrete or mortar, used to produce concrete of fungicidal, germicidal and insecticidal properties. Next question is question number 9. Define hydration of cement. An hydrous cement does not bind fine and coarse aggregate. It acquires adhesive property only when mixed with water. The chemical reaction that takes place between cement and water is referred as hydration of cement. The chemistry of concrete is essentially the chemistry of the reaction between the cement and water. On account of hydration, certain products are formed. These products are important because they have cementing or adhesive values. An hydrous cement compound, when mixed with water, react with each other to form hydrated compound of very low solubility. The hydration of cement can be visualized in two ways. The first is through solution mechanism. In this, the cement compound dissolves to produce a supersaturated solution from which different hydrated products get precipitated. The second possibility is that water attacks cement compounds in the solid state, converting the compounds into hydrated product starting from the surface and proceeding to the interior of the compounds with time. It is probable that both through solution and solid state type of mechanism may occur during the course of reaction between cement and water. The reaction of cement with water is exothermic. The reaction liberates a considerable quantity of heat. This liberation of heat is called as the heat of hydration. Different compound hydrates at different rates and liberate different quantity of heat. Okay. Question number 10 is pozzolana material in natural pozzolana and artificial pozzolana divide categorize. First of all, natural pozzolana is divided as a clay, shell, aplanic chert, diatomaceous earth, volcanic tuff, pumicides. After that, artificial pozzolana contain fly ash, silica fume, blast furnace slag, RHA, MK means methacholine, and then surki. Okay, gentlemen, here you have learned a lot of aspects on the concrete as heat of hydration, pozzolana material, various types of admixture classification, advantage of mineral admixtures, then the different types of mineral admixtures, ground granulated blast furnace slag, chemical composition of silica fume, classification of admixtures, effect of fly ash on concrete, and what is meaning of admixture. These are all topics we have learned here. So gentlemen, all of you, thank you.